All right, so let's get back to these conditional means and try to understand them a little bit better. I want to, because it's so central to identification, is knowing what this conditional mean function is. Um, and it's going to be kind of the subject of the rest of the course. So let's get into this a second. So this identification result suggests a plug-in estimator, okay? Because we know everything we've been talking about in this lecture, identification, this is all population level. We don't have data. This is just pure population level. So it's all pretty abstract. But now the question is, okay, if you have data, how are you going to get to estimate this thing that represents this other thing that you actually care about? So there's like a two-step process, right? This is the causal part, where you have causal identification linking a causal estimand to an observable estimand. And now we're going to talk about the estimation part, which is, okay, how do I figure out what this is? And here, if you're looking at this, you might think, well, let's do a plug-in estimator. That's what we always do with expectations. We replace them with sample averages. So here we now have a sample average where we take this function mu that we have up here, and we just evaluate what the value of mu is for this person at this treatment level. And then if we want the treatment effect, we just take the difference between a equals 1, this thing evaluated at a equals 1, minus this thing evaluated at a equals 0. So it all just depends on this thing here. And what does mu represent? It represents the average outcome that I would observe in this stratum of population with covariate values xi and treatment A. The problem is that we don't know what that is. And here I'm just telling you mu. But what is that, right? So you could imagine that we could estimate that in each stratum, for each stratum of the population, right? Let's say you have 3 strata of X, 2 strata of A, so then you have to calculate 6 different means here, right? And that's great, but what happens if X is continuous? Then this is a function, right? This is not then a mean in each stratum, but it's a kind of continuous, it's a function over this continuous covariate. And the thing is that one way or another, we have to estimate it. So this represents the true group means in the discrete setting. If we could estimate those with sample averages in each of those things, then that would be putting the hat on it. But more generally, if this is just a function, we need to guess what that function is. So what does that look like? This is called regression, by the way. So we have a function of x, and we don't know what it is, and we need to guess what it is. That process is called regression. And so let's look at, this is the plug-in estimator for ATE. We have our estimated function. We evaluate that at x for a equals 1. Take the difference x equals 0, average over those. So let's see what that looks like. That whole process. How do we construct something like this conceptually? We're going to start with the data. Let's say these are the data we have. So we have our confounding covariate, and we have our outcomes for the people who are not treated and the outcomes for people who are treated. We're going to estimate these functions. How do we do that? Basically, conceptually, think of it as drawing lines through the points. So we're going to draw lines that kind of fit the data. We're going to draw one for the gray and one for the pink. Okay? And these are just the lines that appear to fit the data. And how to do that is going to be the subject of the rest of the course. But here I just want you to understand conceptually why we're doing it and what we're going to do with those things once we have them. So these dotted lines represent our approximation to the conditional means, which we can get by fitting lines through the data. Now, at each of the observed values of the covariate, so we had these 8 data points. I'm just going to drop them down to the x-axis and say this is where our data lie. For each of them, I'm going to ask from the conditional mean functions, what are the values of the basically, if I took this person and I treated them, what would have happened? If I took this person and I didn't treat them, what would have happened? For each person, I'm going to generate those 2 counterfactual predictions. And then I will compare them. So now I can just move those all over and look at the average of the counterfactual predictions for this group and the average over here. And that is our estimate of the treatment effect. So notice that each person, here we have a particular person. Each person is contributing to this and to this because we have their predicted values under both settings, right? And so this dot and this dot are from the same person originally, right? And so on and so forth. So we have 8 values here and 8 values here, and we're taking the average of both of them. So I'm trying to give you some visual intuition for what I mean when I was saying, mu hat of xi. You could also think of this as a mutate, like we've seen before. So you have a data set where you have x, a, and y, and then you're going to do a mutate. You're going to figure out what this function mu hat is, and you're going to apply it as a mutate to x to generate a new column, and that's going to be these values. And then you're figuring out what this function is with the 0 here, and do a mutate to get a column with these values, and then you're going to average those two columns and take the difference. And that is functionally what we're going to do to compute these counterfactual predictions. And we know we're going to study the properties of doing that. We know that these sample means are normally distributed for a fixed function, mu. So how does it work when this is now kind of like a random function that we're learning from the data as well? So different data set, we would get different functions. How does that change? How does that behave? How do we understand what the sampling distribution of our estimate of this thing is? That's all what we're going to do for the rest of the course, basically. Okay, so that's the big picture. Hope you got something out of it, and see you in the next lecture.